What's up, everybody? My name is Dana Harris with Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I'm going to show you how to factor using the greatest common factor. So, we know we factor quadratic equations and expressions, but we're going to start off by factoring out the greatest common factor. So let's get into example 1. Example 1, I'm going to be given a quadratic expression 16p to the fourth power plus 4p to the third power. And in order to factor out the greatest common factor, I need to look at both of these terms and see what is the greatest common factor of each of these terms. Now, 16, when I first look at the coefficients, 16 and 4 have a greatest common factor of 4. So I'm going to write that. So the GCF equals 4, and then p to the fourth power and p to the third power, you always want to take the smaller exponent. And the way I like to explain this is that this p has 4 p's, but this one only has 3 p's. So I can only take out 3 of them in common. Okay, so they only have 3 p's in common. So if I have the greatest common factor of 4p to the third power, I'm going to write that on the outside of the parentheses. Now, to figure out what I get inside the parentheses, I'm basically taking each of these terms and dividing them by the greatest common factor. So it's basically like saying this divided by 4p to the third power plus that second term divided by 4p to the third power as well. Okay, so what that leaves me with is 4p to the third power on the outside of the parentheses, and then 16 divided by 4 is 4, and then p to the fourth power divided by p to the third power, all we have to do is subtract the exponent. So 4 minus 3 is p to the, actually I'll write it like this, p to the 4 minus 3 power, and then plus this number 4p to the third power divided by itself is equal to 1. So we're left with 4p to the third power times 4p plus 1. Okay, and this right here is actually how it's factored. Okay, so we took this and now we found the greatest common factor, and then in order to find out what's in parentheses, we take each of these terms and divide them by the GCF. And that's it. Let's look at the second example. Example 2. Example 2, I have 63. That's not a 3. Let's say like this. 63x to the 12th power. And then minus 35x to the 6th power. Okay, so we need to figure out what is the greatest common factor between 63 and 35. And in this case, they are both divisible by 7. So the GCF here equals 7. And then once again, I have 12x's here, but only 6x's there. So they only have 6 in common. So the GCF is 7x to the 6th power. So I'm going to write that. And then parentheses, remember 63x to the 12th power. I'm going to divide that by 7x to the 6th, and then minus 35x to the 6th power divided by 7x to the 6th power. This step is just an extra step because I try to make sure that I don't assume anybody knows anything. So I'm showing every single step, okay? So then when I do the division here, I'm left with 7x to the 6th power, and then 63 divided by 7 is 9. Once again, we subtract the exponent. So 12 minus 6 is x to the 6th power. And then 35 divided by 7 is 5. And then x to the 6 divided by x to the 6 is just 1. So here, 7x to the 6 times 9x to the 6 minus 5. And those are factored. Okay. Now, these are just basic examples to kind of get you started. I like to do things progressively with these videos because depending on what grade level you're in or what familiarity you have with these, they can be a little tedious and a little difficult. So I break the different types of problems down into different videos. So let's do 2 more examples and then wrap it up. So example tree. And for those of you that aren't familiar with why I say tree, there's a video on that. 10 n to the third power minus 9n squared plus n. So in this case, I have 3 terms, all right? And I need to figure out what is the greatest common factor, okay? Now, notice, this third term does not have a coefficient. So the first 2 do, so that means there is no coefficient that is part of the greatest common factor, okay? So there is no coefficient, so all we can do is look at the variables. Now, once again, this one has 3 n's, this one has 2, and this one has 1. That means they only have 1 n in common for all 3 terms. So our GCF this time is just n. So we're going to write n, parentheses, 10 n to the third power divided by n, minus 9n squared divided by n, and then plus n divided by n. And that's going to give us 10 n to the second, because even though there's no exponent on n, it's understood to be 1. So 3 minus 1 is 2, and then minus 9 n to the second over n to the 1 is just n, and then plus 1. Any number divided by itself is 1. So our final answer would be this right here, okay? And example 4, let's do one more type of example, see what we get here. This one we have 32t to the third power. Plus 28t minus 20. Okay, notice we find the GCF first, and in this case, all 3 terms don't have a variable. So that means that there's not going to be a variable as part of the GCF. But let's figure out what is the largest number that 32, 28, and 20 are divisible by. And in this case, I believe it is 4. It is 4. So the GCF in this case is 4. So we're going to say 4 parentheses 32t to the third power. We're going to divide by that GCF. 28t divided by the GCF. Not yet. Minus 20 divided by the GCF. Okay, so 32 divided by 4 is 8. Keep the t to the third power. 28 divided by 4 is 7. Keep the t. And then minus 20 divided by 4 is 5. So here is the factored form. Okay, so remember, sometimes the GCF may have a coefficient as well as a variable term. Sometimes it may just have a variable. Sometimes it may just have a number. Nevertheless, we first always want to look for the greatest common factor whenever we are trying to factor a quadratic expression. Thank you so much, everyone, for watching this video. Do me a great big favor. Subscribe to the channel. Share it. Share these videos with someone that you know that may need the help and things like that. Do me a great big favor as well. Go to Instagram. Follow me at YG Math Tutoring, and my Facebook page. Please like the Facebook page at Young Gurus Math Tutoring. Thank you so much for watching and helping me to fulfill this vision of helping students all around the world do better in mathematics. I have a passion for students in mathematics, and I'm doing everything that I can to help bridge this gap of students that are struggling with mathematics. We know that the STEM fields and STEAM fields are growing drastically, and we need more kids that can do mathematics and that can understand mathematics. So thank you once again. Remember, Young Gurus Math Tutoring. I've got the solution to your math problem.